Hello friends, welcome back to our channel Mirror Neuron, which means watch and learn, and this is the part of the video from our daily tips. Okay, so today we are going to talk about three terminologies, and this is pertaining to the field of AI and deep learning. So in 2020, I think you should also keep an eye particularly for these three terminologies and try to gain more knowledge and experience around it. And these are going to be quite mainstream in coming few months or maybe in a year, but you should be quite familiar with these terminologies if you're preparing for a deep learning or an AI related job interview. So the first term is quantization. You might have already read about it, but if not, then I think it's a good time to explore a little bit about this term. So we all know about deep learning, and also quite familiar that heavy and complex algorithms run on a large graphical processing unit commonly known as GPUs. Google also has something called TPUs, right? And that is far from the ideal condition, right? We can't have a GPU everywhere, like in mobile devices, etc., right? Hence, a relatively new family of deep learning methods called quantized neural networks have appeared to answer this problem. All right, and various teams are working across the world on these quantization methods, among others, for enabling efficient, high performance deep learning computation on small devices. I also would advise to look for hardware-aware, automated quantization. And recently, there are many papers from Google and Facebook's, open source frameworks also have introduced quantization to boost models, the training speeds, right? And currently, I haven't seen any books yet, but you can read the research paper online. Okay, so the first thing is quantization. What is the second term that we are going to discuss today is called multi-model training, right? And what is this is AI that relies on multiple media for training and multitask learning, which involves networks designed to complete multiple tasks at once, right? So that the information in real world comes as different modalities, right? For example, images are usually associated with tags and text explanations, and the text contains images to more clearly express the main idea of the article, right? Now, different modalities are characterized by very different statistical properties. Let me give you an example. Images are usually represented as pixels, right? So if you have an image, it will be in the form of pixels intensities or outputs of feature extractors, whereas words and text are represented as discrete count vectors, right? Hence it becomes important to be able to discover the relationship between these different modalities. So say this is picture, right, where we have the pixel intensities, and then we have, say, hello, how are you, and then we try to convert them into word vectors, which is a different model, right? So we try to combine these two modalities. And let me give you a simple example of multi-model learning model is, if you combine two deep Boltzmann machines, right? And each corresponding to one modality. So one of them will be this one, another will be the word vectors, and trying to discover a relationship between them. And when we have two DVMs, on top of that, there will be a additional hidden layer to represent the joint relationship. Okay, so this is the second part. And the third term that you should be quite familiar with, let me adjust the camera a little bit. Yeah, the third term is called the generative adversarial networks. And you must have recently seen that they are called as GANs, and they have created very realistic images of human beings, which you cannot even say whether it's a real human or just created by computer graphics, right? And from the Wikipedia definition, it says that a generative adversarial network is a class of machine learning systems invented by Ian Goodfellow, who also wrote a very good book in deep learning, although that book is filled with all the mathematical derivations. So you have to, if you have interest in the mathematical part as well, that book actually covers everything, almost everything. So what it says is GAN is a say two neural network contest with each other in a game, right? And given a training set, this technique learns to generate new data with the same statistics as the training set. Okay, so for example, a GAN trained on photographs can generate new photographs that look at least superficially authentic to human observers, having many realistic characteristics. Though originally proposed as a form of generative model for unsupervised learning, GANs have also proven useful for semi-supervised learning and fully supervised learning, and also in the reinforcement learning. So the deep learning book by Ian Goodfellow is mentioned in the description section. So if you're not into books, then I would also say DataCamp has a very good course on deep learning using Python, and you can get started from there as well. All right, so I hope these three terminologies, quantization, multimodal training, and generative adversarial networks, commonly known as GANs, I think you should be familiar with these terminologies because these are like the hot topics these days. All right, so I hope you have found something useful information today. So stay tuned and please subscribe our channel.